Better. Okay.
No, ma'am, it's still blur.
Oh. Okay, because first 2 hours I have taken class here. I used the same board. That's it. Okay, when we solve the problems, I will erase everything proper. Before that, I will dictate the theory part only. I will dictate. Okay, guys. Today we are the last class. What I
Ma'am,
have
what is the
given in the
first
last
letter,
class?
first word?
Wait a minute. What I have given in the last class?
Kerry Hamilton theorem.
Hamilton theorem. Okay, we will complete it in the last class. Today we are going to see the diagonalization. Okay, diagonalization of a D. First letter is D. Diagonalization of a matrix by orthogonal transformation. Heading. Diagonalization of a matrix by orthogonal transformation. Okay, guys. First, I will give you the working rule to find the orthogonal diagonalization matrix. Okay. Working rule to for diagonalization. First, step 1. Step 1. Guys, are you writing?
Yes, ma'am.
Step 1. To find characteristic equation. To find characteristic equation. Step 2. To solve the characteristic equation. To solve the characteristic equation. Step 3. To find the eigenvector. To find the eigenvector. Fourth one, form the normalized matrix. Form the normalized matrix N, capital N. Form the normalized matrix capital N. This is fourth point. Fifth one, find N transpose. Find N transpose. Sixth one, calculate AN. A given matrix, N normalized matrix. Calculate AN. Seventh one, calculate D equal to N transpose into AN. N transpose into AN. That is D. Okay, guys, one by one, tell me what's the first step? Step 1.
To find
Find the
characteristic
characteristic
equation.
Characteristic equation. We know very well how to find characteristic equation. In step 2,
Solve the characteristic equation.
okay, solve the characteristic equation. What will come?
Eigenvalue.
Eigenvalues. Okay, exactly. In step 3,
Find the
Find the
eigenvalue.
find the eigenvector for each eigenvalue. Okay, step 3 over. And then form the
And then form the
normalized
normalized matrix.
matrix N and then find the n transpose. We know that n, we can easily write the n transpose and then calculate a given matrix into normalized matrix. Finally, we have to write the diagonalization matrix D equal to n transpose into an. Okay, guys.
Yes, ma'am.
Okay, and then I will give you yes. Okay, next you write the normalized matrix. One second. Okay. If x equal to x1, x2, x3, if x is equal to x1, x2, a column vector, okay, that is an eigenvector. If x is equal to x1, x2, x3, then the normalized vector of x, then the normalized vector of x, then the normalized vector of x is x1 by L, x2 by L, x3 by L. x1 divided by L, x2 divided by L, x3 by L. Here, L is equal to root of x1 square plus x2 square plus x3 square. Okay, guys. Okay. In case if we get the first eigenvector x1 is 1, 1, 1. What is the normalized form this eigenvector?
1 by root 3.
1 by root 3.
See,
1 by root 2, 1 by
x1
root
by
3, 1 by
L, L is nothing but root of x1 square plus x2 square plus x3. 1 square root of 1 square plus 1 square plus 1 square, that is root 3. That is 1 by root 3, 1 by root 3, 1 by root 3. This is the normalized form for this eigenvector. Okay, guys? Any doubt?
No, ma'am.
Okay, we can solve the problem. Okay, write down the question. Diagonalize the matrix. Problems. Diagonalize the matrix. Three, 1, 1. 1, 3 minus 1. 1 minus 1, 3. Three, 1, 1. 1, 3 minus 1. 1 minus 1, 3. Okay. First,
Ma'am,
in
can you
the-
again repeat the question? The matrix.
diagonalize the matrix.
No, no, that.
1 values.
Yes, 3, 1, 1.
Minus 1, 3, 1, minus 1. 1. See, this is not visible.
No, ma'am, in my it's blur.
Oh.
No,
3
it's clear.
plus,
It's clear, we can say.
okay, first row 3, 1, 1. In the second row 1, 3 minus 1, third row 1 minus 1 3. I think you have to change your receiving clarity in your laptop. Megapixel. Did you change in the setting? Guys. Okay, first in the as usual way, find the eigenvalues and eigenvectors. Thereafter, I will explain. You find out eigenvalues and eigenvectors. Then I will explain. S1.
9. 9.
9. S2.
24.
24.
24.
S3.
16.
16.
16 or 15.
16.
16.
16.
Lambda cube minus 9 lambda square plus 24 lambda minus 16 equal to 0. Then find the eigenvalues. Lambda
4, 4, 1.
1 4 4. Okay, guys, got it? Everybody?
Yes, ma'am.
Okay, hereafter what we have to do? Eigenvectors. We need to find the eigenvectors for each eigenvalue. Okay, before that, see, look at that the eigenvalues. This is repeated eigenvalues. Two eigenvalues are repeated. If we get repeated eigenvalues, we have to check the given matrix. This is symmetric or non-symmetric? Symmetric. This is symmetric with the repeated eigenvalues. How can we find the eigenvectors in this method? This is which case? Overall, there are 4 methods. Fourth type. This is fourth method. Last method. That is, in case 1, take lambda equal to 1, find the first eigenvector. In case 2, take lambda equal to 4, find the second eigenvector. In case 3, using orthogonal condition, you have to find the third eigenvector. Am I right?
Yes,
Right?
ma'am. Yes, ma'am.
Understood
Yes.
what I'm saying? Okay. In the as usual way, find case 1 and the case 2. Case 3, I will explain. Case 3 also you know very well. You find the eigenvector and thereafter I will explain. X1,
-1, 1, 1.
X2,
0, -1, 1.
we can easily check our answer is right or wrong because this is symmetric matrix. Symmetric matrix eigenvectors are orthogonal to each other. 0 it becomes -1 plus 1 0. Okay, sorry. Okay. Third eigenvector x3
2, 1, 1.
Yeah, we can check with this. 0 -1 plus 1 0 -2 plus 1 plus 1 that is 0. Okay, all the three answers are right. In case if you get different answer, check with that orthogonal condition. Then only I know we know that our answer is right or wrong.
Ma'am, what is first eigenvector x1 equal to?
Tell me.
First eigenvector
1
lambda
1
equal to 1.
lambda equal to 1 -1 1 1. What is your answer?
0 1 1.
No problem. X1 or x2?
X1.
0 how will come? Okay, no problem. You find the second eigenvector, check with that orthogonal condition. Okay. I think the 0 will not come. Okay, no problem. You find the second eigenvector. When we check orthogonal condition, we can easily identify our answer is right or wrong. This is right. According to that x1 and x2, the x3 is also. See guys, we can check our eigenvalues also right or wrong. I told you no, the sum of the eigenvalues equal to sum of the main diagonal elements. Sum of the eigenvalues is how
9.
much? 9. Sum of the main diagonal elements 3 plus 3 plus 3, 9.
9.
Eigenvalues are correct. Next. Did you finish up to this? Or anybody calculating? Okay. Because hereafter I have to explain. Guys, did you finish? Eigenvector. So,
Yes, ma'am.
okay. Now we are going to write the normalized form. Okay. For each eigenvector, we have to write the normalized form. Now for x1, x1 is -1 1 1. Guys, this is visible.
I'm slightly blurred.
Oh. One second. Okay.
Yes, ma'am.
Now,
Yes,
what is
ma'am.
the normalized form for this?
Minus 1 by root 3, 1 by root 3.
Minus 1 by root 3, 1 by root 3, 1 by root 3. For x2,
0.
0. Minus 1 by root 2.
0,
Minus 1 by root 2.
minus 1 by root 2, 1 by
Root 2.
x3,
2.
2 by root 6.
1 by root 6.
okay. But no need to separately like this for your understanding purpose. And the first problem only I am writing in this step. Okay, directly we can write M matrix. Therefore, the normalized matrix M is equal to, this is our first column, second column, third column. Minus 1 by root 3, 1 by root 3, 1 by root 3. Okay, directly we can write this. And then 0. Third column. Okay, any doubt? Writing normalized matrix. Guys,
Ma'am, how to write normalized matrix, ma'am?
this one. This is understood?
First one root 3, second one root 2, and third one root 6. How did we get those values, ma'am?
Okay. What is the normalized form definition I gave you? No? Did you write the definition? Normalized form. You did not write?
No, ma'am.
Oh, why? X1 by L, X2 by L, X3 by L. Okay, here L is nothing but root over X1 square plus X2 square plus X3 square. Okay, here eigenvector is minus 1, 1, 1. Okay, here x1 is minus 1. X1 divided by root of X1 square plus X2 square plus X3 square. Minus 1 by root of minus 1 the whole square plus 1 square plus 1 square, that is root 3. Okay, here 0, minus 1, minus 2, root value what will come? 2 will come.
Okay, ma'am.
0, minus 1 by root 2, 1 by root 2. Here 2 square 4, 4 plus 1 square, that is 1, 1 plus 1, that is 6. Okay,
Okay, ma'am.
understood. Okay. And then again we have to write the, in matrix form we have to write, this is our first column, second column, third column. Understood?
Yes, ma'am.
Okay. Now we have to write, what is the next step? What we have to do after writing the normalized matrix?
AN. AN.
No, before that.
N transpose.
N transpose. What does N transpose means?
Ma'am, rows into columns.
Rows and columns.
Yeah, just you interchange rows and columns. Guys, write everything clearly. This is not a theory class. This is maths class. Each and everything I am giving. You write everything properly. In the next step. What's the next step? After writing N transpose.
Isolate AN.
Ma'am,
N A.
N.
Yeah, you
N
find
transpose.
you know very well. Matrix. Normal matrix multiplication. A matrix, that is given matrix, into this normalized matrix. You tell me the final matrix, I will write. A into N.
Hello, ma'am. Hello,
Yes?
ma'am. Like, why we are finding all these equations like A and N transpose? Means what is the
I'm not getting clearly.
Hello.
Yes, tell me.
And what is the actual use of finding all these equations A and
Yeah. Finally, we are going to diagonalize.
Okay.
We need that final diagonalization matrix. That's why we are finding. This is the procedure.
Okay.
Okay. Guys, got the answer? AM.
One by root 3.
Tell me.
1 by root 3, 0,
1 by root 3.
0.
It's minus 1 by root 3, I guess.
Ma'am, it's minus 1 by root
Minus 1 by root
Minus 1 by
0,
8 by
0,
root 6.
8 by root 6,
8 by root
by
6,
root 6, 1 by root 3, 1 by root 3, minus 4, minus, ma'am, the second term, second column, that is minus 4 by root
second is
2,
minus 4 by root 2.
minus 4 by root 2,
Second one.
Ma'am, ma'am, A22 is minus 4 by root 2. Yes, ma'am. And yeah, ma'am, then is 4 by root 6.
Ma'am, it's not minus. Plus
Ma'am, it's not minus, it's 4 by root 6. Ma'am, then 1 by root 3. Then 4 by root 2. Then 4 by root 6.
Everybody check with your answer. Next, D, that is diagonalization matrix, N transpose into AN. N transpose into AN. This into this. N transpose. into AN. Okay, we have to multiply these two matrices, we'll get the final answer. Okay, listen here, guys. Listen here. The normal matrix multiplication only. First row into first column. Minus into minus plus. What will come?
Ma'am,
What?
what?
1 by
1/3.
1 by 3. 3.
3. 1/3.
Ma'am,
1
1.
by 3.
It is
1 by
1
3 minus 1 by root 3 into minus 1 by 3, that is minus and minus plus root 3 into root 3 becomes 3, that is 1 by 3 plus 1 by 3 plus 1 by 3, and this becomes 1 by 3 plus 1 by 3 plus 1 by 3, 3 by 3, that is 1.
1, 1.
1.
Okay, and then again first row second column, first element is 0, and next minus 0 minus 4 by
Root 6
root 6 plus
plus 4 by root 6.
What will be the value?
0.
0.
Second element 0. Next third. 8 by minus 8 by root 18 plus 4 by root 18 plus 4 by root 18. What is the answer?
0.
0.
0.
Third element also 0. Okay, next. Second row, first column. First element 0. Next. Minus 1 by root 6
Root 6.
plus 1 by root 6.
0.
Next. Second row, second column. First element 0 plus 4 by root 4.
Plus 4
4
by
by 2.
4
Minus
by
4 by 2. Sorry, plus 4 by 2 and
it will come 4.
That is 8 by 2.
Yes, ma'am. 8 by 2, 4.
That is 4. Okay. Second row, third column. First element is 0 minus 4 by root 12 plus 4 by root 12, that is 0.
0.
Okay. Third row, first column. Minus 1 by root 18. Sorry, minus 2 by root 18. I will write here.
0.
Plus 1 by root 18 plus 1 by root 18. Yes.
0.
Okay, that is 0. Next, third row, second column. First element is 0. Minus 4 by root 12
0.
plus 4 by root 12, 0. Next.
0.
No. 2 8s are 16. 16 by root 36. That is 6. Okay. Into root 6 into root 6.
4.
Next two terms are, yeah, I will write here.
4.
Here.
4.
4.
4 will come. 4 will come. Okay. 16 by 6 plus 4 by 6 plus 4 by 6.
4 by 6.
Plus 4 by
24, that is 4.
4.
This is the our final answer, diagonalization matrix. Now we can easily check our answer is right or wrong. See what is this diagonal elements here.
9. 9.
Sum is
1,
9.
4, 4. This is our eigenvalues.
9.
Okay. That 1, 4, 4. What is our eigenvalues?
1, 4, 4. Yes, ma'am. 1,
4,
4.
4. Eigenvalues only will come in the diagonal elements. All the remaining elements will be 0. Always.
And we can write it directly now.
Mom, then we
Just
can
tell
do
me.
it directly, no, mom.
And we can write it directly.
They won't give marks. We have to show all the steps.
Okay.
Okay. But we know the
But in
final answer. This
MCQ,
is
ma'am,
what.
MCQ.
See, listen here. In case if you write directly, according to our eigenvector, this will vary. In case if we get x1, x2 different, here 4 will come. Instead of x1, in case if we take first x2,
Okay.
what I am saying understood.
Yeah.
If we take
Ma'am, we
in
will
case
find
1,
x1, x2, then we will.
in case 1, if we take instead of lambda equal to 1, lambda equal to 4. Okay, the second eigenvector only, na, our first eigenvector, here 4 will come. Okay.
Okay,
Here
ma'am.
1 will come.
Okay.
1 4 4 or 4 1 4 or here 1 will 4 will come, here 1 will come, or here 4 4 1 will come. According to our eigenvector, this will be. Guys, what I am saying understood?
Yes, ma'am.
Yes, ma'am.
Yes,
Got it.
ma'am. Yeah.
Is it clear? If you have any doubt in this method, ask me.
No doubt, ma'am.
Guys, if you have any doubt in this method, ask me. Screen is low. Today, 9 to 11 o'clock, I have taken 2 periods class in the same, using the same border. That's why not visible clearly for you. Not visible. Okay.
And n means adjoint of n.
Tell me.
N
Just normal multiplication a into n.
Okay, ma'am.
You don't apply any other method here, okay? Only we have
Okay,
to
ma'am.
use this method. Okay, guys? 1 second. Hello? இல்லையே இனிமேதானே முடியும் 40 minutes-ல 1 hour. Tell me. Guys. You asked me, no? Any doubt?
No, ma'am.
No, ma'am.
Okay, no,
No,
doubt.
ma'am.
Anyway, okay. Next, we will go for the next method. Okay, I will give 2 problems for your practice in the same method I will give you for the practice. Can I rub this side?
Only one.
Huh? Anybody's writing?
No, ma'am.
Yeah, one student asked out. In this case, even we can do when eigenvalues are different. No problem. In case if we get a different eigenvalues for the given matrix, symmetric matrix with a non-repeated eigenvalues means in the as usual way find case 1, case 2, case 3. Okay, no need to apply orthogonal condition. In the as usual way, we can find the eigenvectors and then you apply the same procedure. Okay? Okay, guys?
Okay.
Next problem, diagonalize the matrix. A equal to.
Ma'am,
Yeah,
the board is not visible.
in this problem, different eigenvalues will come.
Ma'am, the board is not visible.
It is visible.
Yes, ma'am.
Yes, ma'am.
I just write only that question. This is homework problem. Next I will move to the next topic. Anyway, in the next topic also again we are going to find the same diagonalization only. One problem. Okay. Next heading. Did you write?
No, ma'am. Wait for time.
Okay. Right. In the next topic, just I will give you some introduction part. Guys, did you finish?
Yes, ma'am.
Yes, ma'am.
Okay, ma'am. Next topic. Quadratic form. Quadratic form. And hyphen. Reduction of quadratic form. Reduction of quadratic form. Reduction of quadratic form to canonical form. Canonical. CANNONICAL. Reduction of quadratic form to canonical form by orthogonal transformation. By orthogonal transformation. This is the heading. Okay, next I will give the definition for a quadratic form. Did you write the heading? Guys?
Yes, ma'am.
Okay, ma. Next definition. A homogeneous polynomial of the second degree a homogeneous polynomial of the second degree in any number of variables is called a quadratic form. Is called a quadratic form. For example,
In any number of
number of variables is called quadratic form.
Okay.
Example, Q is nothing but quadratic form. Q is equal to x1 square plus x2 square plus 3x3 square minus 2x1 x2 plus 4x2 x3 minus 6x1 x3. Is quadratic form in three unknowns x1 comma x2 comma x3. Three unknowns x1 comma x2 comma x3. In case if you want to write in the matrix form, the same equation if you want to write in the matrix form, this is the general form. Okay, this is the general form for writing in the matrix form. See?
Ma'am,
First row.
repeat.
Huh?
Repeat, ma'am, once again.
This one or this one?
Yes, ma'am, that one only. Yes, ma'am.
Yeah, is the equation. This example is the quadratic form in three unknowns x1, x2, x3. Okay.
Okay, ma'am.
Next, this is also the quadratic form in the matrix form. Coefficient of x1 square, first row, first element, 1 by 2 into coefficient of x1, x2, first row, second element. x1, x3, 1 by 2 into coefficient of x2, x1. Here coefficient of x2 square, 1 by 2 into coefficient of x2, x3. x3, x2. This is the general form. In the diagonal elements only, coefficient of x1 square, coefficient of x2 square, coefficient of x3 square. And in the remaining elements, 1 by 2 into coefficient of x1, x2. First row, second element. 1 by 2 into coefficient of first row, third element. Second row,
Went
first
down.
element. Yes.
Ma'am, we can't see it downside on the bottom.
Now,
Yes, ma'am.
second row, first element. Second row, second element. Second row, third element. x3, x1, third row, first element. Like this.
Ma'am, what is the second row, third element?
x2, x3. Second row, that is x2. Third element, that is x3. 1 by 2 will come except the diagonal elements. In the remaining all the elements only. Okay, guys. Did you finish? Right?
No, ma'am. No, ma'am.
Okay. Okay. Right. Guys,
Yes,
have you finished?
yes, ma'am.
Yes, ma'am.
Okay, ma'am. Listen here. For example, for this equation, this is also on quadratic form only. Now we are going to write in the matrix form. Okay, using this concept. Tell me in the matrix form for this. First, we can write the diagonal elements. Coefficient of x1 square. What is this?
1.
1.
1. Coefficient of x2 square.
1.
1.
1,
3.
1.
1, 1, 3 diagonal elements. Next. 1 by 2 into coefficient of x1, x2. Coefficient of
Minus
x1,
1.
x2 is minus 2 divided by 2, that is minus 1. Next. x1, x3 is minus 6 by 2.
Minus 3.
Minus 3. Here. x2, x1. See,
Minus
guys, x1, x2 equal to x2, x3.
What, ma'am?
Okay?
Yes, ma'am.
x1, x2 equal to x2, x3. See.
Okay.
The same thing.
Minus 1.
Minus 1. x2, x3.
2.
Here minus 3, here also minus 3 because this is x1, x3, this is x3, x1. Here
2.
x2, x3, 4 by 2 that is 2.
Symmetric matrix.
Do you have any
No,
doubt
ma'am.
writing in the matrix form? Ask me.
no, ma'am.
Okay. Okay, guys. Okay, today enough? That's
Ma'am,
it.
can't see on the top, ma'am.
visible, ma'am.
Which one?
Board
On the top.
Yes, ma'am. Okay. Okay.
Understood?
Yes, ma'am.
Okay. Continuation of this topic next class, okay? Before that, attendance.
Ma'am,
Yes?
for assignment, should we maintain a different book or can we write it in the class notes?
I'm not getting clearly.
Ma'am, for assignment, should we maintain a different book?
Different book.
It means can we do the assignment in our notes copy?
You write all the problems in the A4 sheet and then take a photocopy or a scanner, use that, upload in GCR.
Okay.
Okay? What is the doubt you ask me? Yes. Please mute your mic.